Today we want to learn about complex numbers. Complex numbers are numbers of the form a plus bi, where a is real and b is imaginary. Okay? And a plus bi is the standard form in which a complex number would be written. So if you think of the set of real numbers, we also have imaginary numbers. And together, those make up the set of complex numbers. Okay? So the complex number system is truly the entire number system that we can think of. It is simply the unification of real and imaginary together. You guys got that? All right. So square root of negative 1 is I. Don't ask me why. And when people say that, it's like because you don't understand why. No, there's no why. Okay, there's no why to that. It's like, why do we call a zebra a zebra? Well, it's because we decided one day that something that looked like a donkey that had black and white stripes, we call that a zebra. Okay, that's just what we said it was. You see, this all started from this idea: x squared minus 1 is equal to 0. How many solutions are there? 2. What are they? Plus or minus 1. And one day, mathematicians said, if we're going to say that has 2 solutions, then we must say that has 2 solutions as well. But the only way we can say that has 2 solutions is if we make up this thing called imaginary solutions. And so they said we have these imaginary numbers. We don't understand any application that they will have in real life, but I told you this through the invention of imaginary numbers that we have alternating current electricity. It took hundreds of years for that to develop and to understand, but sometimes the application comes later. So we'll see if you can get this. One group got it, one group did. Square root of negative 1 is I. What is I squared? Negative 1. Good. You guys got it. Way to go. Okay, so what we would like to do is be able to understand how to perform operations on complex numbers. It says perform this operation. This is subtraction. So I have 4 plus 3i, and it's going to be a minus 6 and a plus 8i. And all I do is I combine the like terms together. So I have real terms, namely 4 and negative 6, which make negative 2. And then I have 3i and 8i, which make 11i. And it's written again of the form a plus bi. Everybody okay with that? Next one, I'm going to distribute my subtraction. I have a 1 minus I have a 3, I have a minus I have a minus 6, and I have a plus 5i. Again, gather my terms. I have 1 and 3 and negative 6. Again, make it negative 2. Negative I is negative 2, and then 5i would be making a 3i. Any questions on the first 2 examples? Okay, and as we move on, let's multiply. This gets a little bit more interesting as we multiply. 4i times 7i would be a 28i squared. You can come on in. Yeah, you can come on in. You want to take some pictures?
I just got to interview Brecken.
Okay, well, why is he so popular?
Because he's just like
never want to talk to me. Just always Brecken.
Yeah.
All right, okay. So I write it as I squared, but what is I squared? So therefore you get a negative 28. Sometimes people ask, Mr. Gens, do I have to write the I squared? You don't, but I do think that at times it can be helpful. The next one is a negative 24 I squared. Because I squared is negative 1, this comes out to be what? Positive 24. I'd like you to do these 3 right now on your own and check with a friend to see if you think you got them right. I just had a brilliant idea. What? This would make a perfect proposal. Like somebody come into the room and be like, "Oh, I got to interview you for your book," and they take them out there and they, ask them a prompt. Yeah, you like, yeah. I like it. Did she ask me a prompt?
No.
Oh, shoot! I thought I had it.
Oh, sorry, where were you third on?
Oh boy, I like that. Let's roll. All right, this one 2i squared, which is negative 2. We all good there? Next one, I got 12i cubed. I realized 12i squared times I. That way you can see that the I squared is negative 1. So this ends up being negative 12 times I, which is negative 12i. Again, if you could write it as an I squared, sometimes that helps people. Negative I times I squared. Notice how the I squared is negative 1 times negative I will just be positive I. And you're saying to yourself, I'm really smart right now, and you are. I'm very proud of you, but you're not probably invincible. See if you can do the next one. Talk to your friend about how you're going to accomplish that. And no, don't multiply it out 122 times. Talk to your friends. Take a minute. See if you come up with anything.
Okay,
Think about it.
okay.
Diego, you should multiply it out.
Nope.
It's negative 1.
Oh, wait, yeah.
I mean, negative 1.
Yeah, that's what it would be.
Same thing as well. It's, I see an even, I see an even power here. Probably means something. So I'm gonna say.
Right?
Yeah, my.
It's gotta be.
It's not telling us.
Come on.
They're wrong.
Are you sure it's not positive one?
I squared is negative 1.
Yeah.
And it's squared like.
But if you're multiplying times over and over again, then what's negative 1 times negative 1?
But then you would get 1, but then you multiply 1 by negative 1, and it's negative 1.
Okay, but I is equal to I squared is equal to negative 1. I to the third, that would be I times negative 1, which is negative I, right? And then I to the fourth, isn't that I squared times I squared?
Yeah.
Is that 1?
Oh, shoot, he's right.
Oh, yeah, I am right. All right. So which one is it? I told you it's helpful if you could write it as an I squared, so I'm going to write it as I squared. I to the 122nd power is the same thing as I squared to what power?
61.
61. What is I squared?
Negative 1.
So if I take a negative to an odd power, what does it come out to be? So negative 1 is correct.
Wait, that's not what it said.
Your reasoning was incorrect because I could change this problem right away to be I to the 124th. Watch how that works out. Well, that's I squared to what power? 62nd power. Well, I squared is negative 1, and negative 1 to the 62nd power, that's positive 1. See the difference? So right as I squared can be a helpful piece. Flip it over. As we continue to multiply, you can distribute 3i times 2 and 3i times negative 5i. Notice I get a 6i minus a 15i squared. 15i squared. What simplifies here?
I squared.
Negative 15i squared becomes positive 15. I like to write the 15 first and the 6i next, because we write it as a plus bi. Okay, a plus bi. Do the next one on your own. Do the next one on your own. Did you notice that the two i's canceled? And then you get 4 minus I squared. That will be 4 plus 1. You get a total of 5, don't you? Why did the middles cancel? Because these are what we call what? Starts with a C. Rhymes with conjugate. They are conjugates. And so you can see that when you're multiplying two numbers together that are complex numbers that are conjugates, you are going to come up with a real number as a result. Okay? That's helpful. We will use that as we move forward. The next one, again, we just multiply out. We get 6 times 3 is 18. 6 times negative 7i is negative 42i. I times 3 is 3i, and I times negative 7i is negative 7i squared. We have 18 minus 42i plus 3i, and negative 7i squared is the same as positive 7. So we get 25 minus 39i. We've taken care of the multiplying, we've taken care of the powers, we've taken care of so many pieces, but now we have 4 divided by I. You cannot have an I in the denominator. Anybody want to guess what we do to make sure that the I no longer remains there?
Multiply both by I.
I over I, we get 4I over negative 1, because I times I is negative 1. Notice that 4I divided by negative 1 is a negative 4I. Negative 3 over 2 with I in the denominator. Sometimes people want to multiply top and bottom by 2. You don't do that. You multiply top and bottom by I. And at the top, we get a negative 3I. And at the bottom, we get a 2I squared. I squared is? So the negatives will cancel, won't they? And I just get 3 over 2I. You can place the I on the outside. You can place it in the numerator. Do not place it in the denominator. I accept either one of those. Okay, what's different about the next one? It's not just I, is it? If you multiply top and bottom by I and don't do this, you get 3I over negative 1 plus I. Did that really help us at all? It didn't help us at all. What do you want to do?
Multiply it by I plus 1.
That's what every hour has said so far. Everybody goes to the I plus 1. It's not going to work for us.
I minus 1.
Thank you. That's why I showed you the conjugate, I minus 1. Notice that that will produce for you a real number in the denominator, which is what we want. So in the top, we get 3I. We have a minus 3. And in the bottom, I multiply the I plus 1 and the I minus 1. Again, notice that these are conjugates. And so if you're multiplying conjugates, the middle will disappear. I times I is negative 1. The middles go away, and I get 1 times negative 1 is negative 1. Now, people got a little bit confused when I did this next step. I'm going to take my time, make sure everybody understands. I'm going to write the I second, and I'm going to write the real part first. I'm going to write this as negative 3 plus 3I on top. Is everybody okay with my order there? On the bottom, I have negative 1 minus 1 is negative 2. Again, we like to write it in the form of A plus BI. So in order to accomplish that task, I'm going to separate this into 2 parts. Does everybody agree that 5 plus 1 over 2 is the same thing as 5 over 2 plus 1 over 2? Everybody wrap their mind around that?
Mm-hmm.
That's just property of adding fractions, right? So we're used to going forward. We can also go backwards. So we can write this as negative 3 over negative 2, or 3 over 2, and then minus 3 over 2i. So I could take each part of the numerator and put it over the denominator to separate it into 2 parts. That way I see that this is my A value and this is my B value. Okay. I don't get too picky with that come time to the test. I just want you to see the way things will be expressed on the ACT. Again, I have very high hopes for you guys on the ACT. Juniors who took this class last year, average ACT score was 27.5 for the math. That's not a bad score. Okay? I expect some people here will get 35s, 36s on the math. So let's go. Next one. Go ahead. Multiply by the conjugate. See what you get. I'm going to slowly work it out here so you can check as you're moving along. Maybe another 45 seconds to kind of work that out, check with people, and then I'll work it out for you.
Oh, man. Sorry.
5, 4, 3, 2, 1. Did everybody get that in the top? 10 minus 5i minus 4i plus 2i squared? So the 2i squared becomes negative 2 plus 10 is 8. Then I have a minus 9i. That's what I should see in the numerator. In the denominator, hopefully you saw the middles cancel. If you didn't even write them, that's okay. They're conjugates. You know the middle will cancel. And I get 25 plus 4 is a 29. So I want to see 8 over 29 minus 9 over 29i. Any question there? Okay, I have 2 problems that did not make the list, and they're very, very short, but they come up in your assignment, and I've actually seen them on the ACT. So we are going to simplify the following: the square root of negative 12, and we're going to simplify the square root of negative 5 times the square root of negative 20. So at the bottom of your notes, please write those 2. And I did not put any problems with simplifying the square root of negative 12 because that's something that you've learned in previous years. But how do you simplify the square root of negative 12? Yeah, the square root of negative 4 and the square root of 3. And we say that the square root of negative 4 is 2i times the root of 3. So that's simplifying the root of negative 12. Is everybody okay with that? Now, for the next one, the first time I encountered this problem, I did it incorrectly because the fact is, I walk through that same door every day. The same door where every once in a while I find a problem where I say, oh, I didn't know how to do that either. And the mistake I made is I multiplied these together. I got the square root of 100, and I said that that was 10, and that is incorrect. Okay? And what I learned is that if you have a negative underneath the square root, that order of operation must be taken care of first before you multiply. And so I have to reduce this into its imaginary form, namely, which is I roots of 5. Everybody okay with that being I roots of 5? Times, then that will be I roots of 20. Now when I multiply them together, I times I is I squared. And the root of 5 times the root of 20 is the root of 100. The root of 100 is 10, and I squared is negative 1, so notice you get negative 10 in that situation. That's the answer. And that's the kind of problem I've seen on the ACT. A lot of problems on the ACT are not necessarily difficult, but they expect you to have recall and have you seen it before. A good thing for you juniors, you will have seen basically every possible component that could be on the ACT by the time we get to March. Those of you who are seniors, there are certain things that you unfortunately did not get to see because you didn't get a chance to take trigonometry and some things in this class. But good news for you is that the ACT doesn't matter as much anymore. I will tell you right now that I've seen kids go to college, and you guys are all good students, and so you guys are all going to do just fine. And if you go to private school, they'll offer you scholarships. If you go to public schools, you'll find scholarships through the community. So anyway, that said, there you go. You guys have time to work on your assignment. Wow, you got 17 minutes. You might be able to get the whole thing done.